My dear viewers, welcome to once again the live of the acids and bases of the 10th class chemistry. This is a much more important one, and from the basics onwards you have to learn what is acid, what is base and what is salt. In this case, first of all, quickly and briefly I am coming back. What is the acid in chemistry? This is acid in the sense one substance which is dissolved in water and releasing hydroxyl ions, that is called H plus ions. H plus ions we call hydrogen ions. Whenever one substance which is releasing hydrogen ions, that is called acid. And a substance which is releasing hydroxyl ions, OH ions, we call it as a base. If it is releasing hydrogen ions, that is acid. If it is releasing hydroxyl ions, that is a base. So this is the difference between the acid and base. And here one parameter is there to find out what is acid, what is base. And that parameter also shows that one which is a strong acid, which is the weak acid. And in this parameter, we are having the 14 graduations. 14 graduations, 1 to 14 graduations, and up to below 7 graduation, whatever the values are coming below 7, we consider it is acid. And above 7 to 14, we will consider it as a base. So now already you got what is acid and what is the base. That means once again I will repeat, the substance which is dissolved in water, which is releasing, or we can say which is furnishing hydrogen ions, we call it as an acid. And the substance which is furnishing hydroxyl ions in the water, we call it as a base. Next is, we came to know what is acid, what is base. Now it is a time to know what is a strong acid, what is a weak acid. So here, strong acid in the sense, strong acid means the acid, suppose the acid H2SO4, this is called sulfuric acid. Next thing is HNO3, nitric acid, and HCl. This is what we call hydrochloric acid. This sulfuric acid is having two hydrogens. This nitric acid is having one hydrogen. This hydrochloric acid having one hydrogen. Whenever the acid which is dissolved in water, which is releasing all the hydrogens, not even keeping one hydrogen also, every total number of hydrogens present in the acid are releasing or furnishing, that is called strong acid. So H2SO4 is a strong acid because it is releasing the two hydrogens which is having already, like this, and it is becoming SO4 minus. This is a positive ion, this is a negative ion. And here HNO3 also releasing the hydrogen and keeping the nitrogen, and here HCl. So the acids which is releasing all the hydrogen ions when they dissolved in water, we call strong acids. The strong acids will be, the values will be from 1 to 3.5 below. So above 3.5 to below 6.9 we call as a weak acids. Now I will explain you what is a weak acid. Now weak acid in the sense, we can see here CH3COOH. This is called acetic acid. Acetic acid. And one more thing is H2CO3. This is a carbonic acid which will fill in the cool drinks. And H3PO4. This is a phosphoric acid. phosphoric acid. So here you can see the first acid we are having 4 hydrogens, H3 and here 1. Total 4 hydrogens are there in the acetic acid. When it is dissolved in water, it is releasing only one hydrogen. It is releasing only one hydrogen and it is not going to release the 3 hydrogens. It is keeping itself with the 3 hydrogens. It is not releasing all the 4 hydrogens which is having. It is releasing only one hydrogen. Here also carbonic acid is having 2 hydrogens. Here also it is releasing only one hydrogen. And phosphoric acid also is having 3 hydrogens. It is also releasing one hydrogen. These 3 acids, they are releasing only one hydrogen even though they are having more than one hydrogen. So it is not furnishing, not releasing all the hydrogens present in it. So then these are called weak acids. The acids which are not releasing all the hydrogens present in that. And so this is the difference between strong acid and weak acid. Now comes to the point of how to identify strong base. Strong base in the sense here NaOH, sodium hydroxide, KOH, potassium hydroxide, NH4OH, ammonium hydroxide. Once again, sodium hydroxide, potassium hydroxide, ammonium hydroxide. In this, one hydroxyl group is there. Here also one hydroxyl group is there. Here also one hydroxyl group is there. First one is called sodium hydroxide. Second one is called potassium hydroxide. Third one is called ammonium hydroxide. These hydroxide, whenever they dissolve in water, same situation, they are releasing only one hydroxyl ion. Here also, it is releasing all the hydroxyl ions present in it. Here also releasing all the hydroxyls present in it. Here also releasing all the hydroxyls present in it. If the base which is releasing all the hydroxyl ions which are present in them, we call strong base. And one more interesting point, the base which is dissolved in water, that particular substance is called alkali. What is alkali means? The base which was diluted. Take one acid, put certain quantity of water. That quantity, that mixture we call alkali. Alkali is nothing but diluted base. Alkali is nothing but diluted base which is dissolved in water. Now we go for weak bases. Here, what is the meaning of weak base means? Here you can see CaOH taken twice. This is the calcium hydroxide, or we can call it as a slag lime. MgOH taken twice. This also we can call as a magnesium hydroxide. These are weak bases. When they dissolved in water, they will release only one hydroxyl group, even though they are having 2. It will release only one hydroxyl group because even though it is having more than 1. So these are called weak bases. Right. Now, to measure the strong acid, a strong base, weak acid or weak base, we are having one instrument to measure it, that we call pH scale. That is called pH scale. The pH scale means what it is going to do, how to measure it means the amount of hydrogen ions present in an acid the amount of hydroxyl ions present in base, it will measures and it shows this is a strong acid because of these many hydrogen ions are there. This is a weak acid because these many hydrogen ions are there. This is a strong base because these many hydroxyl ions are there. This is a weak base because of these many hydroxyl ions are there. Like that, it shows us certain indicators and parameters, and that means this is the instrument which shows what is the amount of hydrogen or hydroxyl ions present in the acid or base. That is called pH scale. It is discovered by the scientist Sorensen. Sorensen is a scientist, and this is having 14 divisions, 1 to 14. Below 7, the reading is coming on this scale, all are acids. Even lactic acid, which is present in the milk, and uric acid, that is nothing but urine, and lemon, all these are acids only. And bases means soap, water, and milk of magnesia, like that we having all the circumstances it will identify. But exactly 7 is going to call as a neutral. Okay, either it is neither acid nor base. What is that question means? Why we have to study pH scale, pH values of the different substances means? Because according to the pH value only we have to take the food in our body. If the pH value is more, it will gives different difficult. Example, already you know very well, one point I will tell you. If in our mouth the pH value is 5.5, that means it is acid, because below 7, whatever the reading is coming on the pH scale, that is acid. So the acidity in our mouth is developed, is reduced to below 5.5, then the teeth which is made up of calcium phosphate, calcium phosphate is the strongest element, strongest compound in our body. Which is the strongest part in our body means the teeth, which is made up of calcium phosphate. That strong teeth only is getting corroded. It is getting corroded with the acid which is having the pH value 5.5. If the pH value 5.5 means the acid is very dangerous, it will spoil the coating of this calcium phosphate and it will become brown color the teeth and gums will spoil, and that then we will get lot of problems. Just teeth like that you will say, but you have to remove, you have to keep it in one mind. What is that? Each and every teeth present in our body having a relation, each and every part in our body. Suppose one teeth the dentist is carelessly removed, that the teeth belongs to, responsible to the eye, he will become blind. In another teeth which is responsible to the heart, the dentist is removed carelessly, that is going to be a heart problem for that person. So dentist also almost all equally important to the remaining physician, MBBS doctor. So that is teeth is very important, and the teeth is going to be spoiled if the pH value is less than 5.5. You shouldn't keep the chances in our mouth to keep the pH value is less than 5.5. And whenever the pH value becomes 5.5, the tooth pain starts. That is called tooth decay. So to avoid that one, we keep on drink certain water, a certain coconut water and other diluted things to bring the pH value greater than 5.5. If the pH value in our mouth greater than 5.5, the teeth, calcium phosphate is safe side, no tooth problem is going to come. That is the reason it's important for our case. Next one is in this lesson, water of crystallization. Water of crystallization. What is actually water of crystallization means? One compound which is having certain number of water molecule. Any compound which is having certain number of water molecule is called water of crystallization. For example, here Na2CO3. This is called sodium carbonate. Simply we call sodium carbonate. But this is not water of crystallization. This is just one sodium compound. To this compound, we are adding 10 water molecule. Then it has become washing soda. It becomes washing soda. That means washing soda is a compound which contains 10 molecules of water. To form a, why we are adding 10 molecules of water, that question may arise. Why we are adding the water molecule? What is the necessary means? Only 10 molecules are added. If you are adding more water molecule, what will happen? Less means what will happen? These questions are coming means that also answer we are having. For this sodium carbonate, exactly 10 water molecule are perfectly right to keep a crystal formation. Your washing soda has to become a crystal form. Compulsory you should provide 10 water molecule. Then it becomes perfect washing soda. That should become a crystal form. That purpose we call water of crystallization. And next is another example for this one is CaSO4 2H2O. This is what we call gypsum. Gypsum, actual CaSO4 means calcium sulfate, and we are adding 2 water molecules. We are getting the one gypsum here, the compound. This gypsum is a very important compound in the cement industry. This is, if this gypsum is not added a good quantity in the cement bag, the total powdery rocky cement, the smooth powdery cement will become rock. The next day it will become rock. And total cement is going to be waste. So the gypsum is a compound which is protecting the cement, powdery cement, always keeping powdery cement for years long, making sufficient and supply of the gypsum. If the gypsum is not added, next day, whatever the cement bag you purchase, it will become one rock, cement rock. So you want cement rock? Don't add gypsum. You want nice, beautiful cement? Add gypsum. Now come to the point of one more example for water of crystallization is CaSO4 of H2O. This is what I call plaster of Paris. Plaster of Paris. This plaster of Paris means almost it is a very popular term. Each and every Ganesh idols and the people who got accidents, the bandages point of view, this is substance is most important. And very slightly difference you will find between the gypsum and plaster of Paris. What does that means? Chemicals are same, no doubt. But water molecules is 2 water molecules in gypsum, only half water molecule in plaster of Paris. That means I don't want plaster of Paris. Sorry, I don't want gypsum. I want plaster of Paris means you have to say one thing else. How to get the plaster of Paris by gypsum means just heat the plaster of Paris gypsum at the temperature of 130 degrees. At the temperature of 130 degrees, take gypsum. Heat the gypsum at 130 degrees centigrade. It loses one of water molecule. It retains of water molecule. It becomes plaster of Paris. So the raw material for plaster of Paris is gypsum. Now here one important point is there here. We are want to produce NaOH, one strong base. Then immediately you can electrolyze. That means sodium hydroxide is produced by electrolysis of sodium chloride. Electrolysis. That means this solution you put in one iron tank. Which solution? So this sodium chloride you put in one metallic tank and supply the current. It will divide due to the certain quantity, and you are going to get NaOH. Sodium hydroxide is going to be produced, and this is producing because of the chlorine here, and it's producing the what do you call liquid hydrogen, liquid base. We call it is a what process we call this chloroalkali process. So now that means what is a chloroalkali process means preparing of sodium hydroxide by electrolyzing the sodium chloride is nothing but chloroalkali. To the point of baking soda. What is baking soda? Why it is uses in different occasions means I will tell you. First of all, I will give one equation here. First thing that is the most important, NaHCO3. This is the chemical formula of the baking soda. That means sodium hydrogen carbonate. What is called sodium hydrogen carbonate, or we can say sodium bicarbonate. Sodium hydrogen carbonate or sodium bicarbonate. We are adding some acid, sulfuric acid, and what is the product we are getting means Na2SO4 plus H2O plus 2CO2. Here we are taking the baking soda, we are adding certain quantity of acid to this baking soda, we are getting one salt, we are not bothering about this one, we are getting certain water, we are not bothering about this one, we are bothering this carbon dioxide. Why we are doing this experiment means finally to produce a carbon dioxide. This baking soda is a main component of fire extinguisher. In the wherever the factories, everywhere fire extinguishers will be there. Whenever the fire is caught, we'll press it in that in one glass, in one chamber, baking soda will be there. In another chamber, this acid will be there. Whenever we press it, these both will mix. These both are going to be mixed, and it will form, and it releases a stream of carbon dioxide. This carbon dioxide main function is to put off the fire. Okay, with this we will use as a fire extinguisher. What we call fire extinguisher. That means in all fire engines point of view. And one more thing is, this baking soda is also using in cooking point of view, cooking agent. Why we are using cooking agent? If you want to idli, we will add this baking soda. Morning the dough will get nice fluffy nature and loose and spongy and even bread and so many other things else point of view. And so here cooking agent point of view also baking soda is useful. To put up the pile also this baking soda is very useful. Next is bleaching powder. Bleaching powder, the form of the bleaching powder is CaOCl2. CaCl2 means calcium chloride, but here CaOCl2 is oxygen is also there. That is the reason we call chemical name of this one is calcium oxychloride. This is the chemical name of the bleaching powder. It is the main purpose of this bleaching powder is what we call used in disinfecting the drinking water. To kill all the germs in drinking water, this is going to be used. So the main use of this one is disinfecting the drinking water to kill all the waste germs present in the drinking water. We will use this bleaching powder. Chemical name is calcium oxychloride. Now, I am going to explain about the indicators. What are the indicators we are applying to the acids and base? Means first of all, methyl orange. Methyl orange. This is light orange color. Whenever this methyl orange indicator is added to acid, few drops of methyl orange is added to acid, the acid is going to change in the color of red. The acid changes which color? Red color. And next thing is, if this methyl orange is added to base, you are going to have yellow color. If it is whenever the orange color methyl orange added to base, it is giving the yellow color, then only it is a base. Methyl orange color methyl orange added to base, if you are getting yellow color the total solution, then only we can call it as a base. If it is not getting yellow color, this is not a base. If it is getting red color, this is an acid. So methyl orange gives red color to the acid, yellow color to the base. You have to take spelling properly of this one. Phenolphthalein. PHENOLPHTHALENE. PHENOLPHTHALENE. Phenolphthalein. Whenever this phenolphthalein I am adding to the acid is not giving any color of kindness, just it is giving colorless liquid. It is giving colorless liquid. That means no effect of this indicator in acid. But this phenolphthalein is added to base, you are getting pink color. You are getting pink color. So pink color you got with the help of the indicator phenolphthalein, that is the base. And the colorless liquid you got with the help of the phenolphthalein indicator, that is acid. One more indicator I am going to give you. Bromo thymol blue. This is very important indicator, bromo thymol blue. And whenever this indicator we add to the base, it will give completely blue color. Whenever this indicator we are adding to the acid, you will get yellow color. So with the help of the bromothymol blue, you add to the acid, you will get yellow color. You add to the base, you will get blue color. Now comes the point of olfactory indicators. Olfactory indicators. What is the meaning of olfactory indicators? Means substance which have different color in acid and base. Any one substance which is giving which is giving different odor, different smell. That means it is giving different smell with acid, different smell with base. Different smell with acid and different smell with base. Example I will tell you. Vanilla. You will take vanilla. This one, whenever we add this vanilla to the what you call acid, whenever you are adding vanilla to the acid, you will get one beautiful pleasant smell. Pleasant smell. Vanilla you added means you will get interesting pleasant smell. And same vanilla if you are adding so now here vanilla which is reacting with the acid is giving pleasant smell, which is reacting with base it is giving no smell. The substance which is giving pleasant smell with base. Some other examples for this what you call olfactory indicators means onion and vanilla I already explained you here, and clove oil. Clove oil, this is used for the whenever the tooth pain severe is coming means the clove oil is going to be touched there. So that is the situation. Now comes the point of neutralization. Neutralization. Neutralization reaction here. What is the meaning of neutralization reaction? First of all, I want to give one example for this one. NaOH plus HCl gives rise to NaCl plus H2O plus 13.7 kilocalories of heat. Here, what is a neutralization reaction means? Take one strong base NaOH, take one strong acid HCl, both are strong. Acid also strong, base also strong. And you won't get in the result, you are not going to receive acid, not going to receive base. You are receiving salt, water only. Every time try to remember here, whenever the strong acid, strong base are reacting each other, the result will be salt and water. A strong base and strong acid is reacting each other. That one, 13.7 kilocalories of heat is released. 13.7 kilocalories of heat is released. Why we call it as neutralization? Because in the result, no acid, no base. It became neutral. It is becoming salt and water. This is the reason you are getting heat of neutralization reaction. One more thing is, whenever you are reacting with the weak acid plus weak base, if you are reacting weak acid and weak base, here also you are getting salt and water. Salt and water, and here also heat is going to be released, but that is 13.3 kilocalories of heat is going to be released, not 13.7